So for number 19, we've got some quadratic function, and we're going to a generalized one. So these, so don't think too much about. We're not actually trying to find that. Okay, this is 1, 2, because we don't have these units. So we have no idea where these particular points are. What they want us to do is to write an expression of these values in terms of the coefficients A, B, and C. I'm in the wrong place here. Here we go. So we're not trying to find specific numerical values for these, but just sort of generalize. So for the vertex, actually, let's start with the y-intercept. That's the easiest one. This is going to be the place where, as we can see, x equals 0. So if you put in zeros for x's, A and B go away. When x is 0, y is going to be C. So the y-intercept is really the easiest one of all of these. It's just going to be C. Or if you want the point 0, C. And I like to do that because x is 0, y is C. That would be its expression. Or y, the y-intercept equals C. It's another way to think of it. We'll go to the roots next, not next, but last. The vertex is the next sort of easier because it's a single point. The x-coordinate of the vertex is going to be equal to minus b over 2a. And again, why is that? It is because it is. It works. So that's the x-coordinate. The y-coordinate would be the function value at x. So we're plugging in x, so it would be whatever that function value is at minus b over 2a. You plug it into the function, blah, blah, blah. If you had your a and b, you would get the y value now. So that's going to give you your actual vertex point. So then finally, the x-intercepts, that's the place where y equals 0. So it's where the function equals 0. And what we've looked at is, let me change the color here to something like that. So if here is the vertex going through here, remember there's there is a vertical line. Let's make it violet. That goes through the vertex. Let's see if I can, if I got it vertical, pretty close. So that's the line of symmetry, the axis of symmetry, what we call, and so it's symmetric about that. And so what we know is the distance here, curly braces, is going to be the same as the distance here. And so we take our, so notice we've got our x-coordinate of the vertex is this. And so for each of these, this one, this particular root will be the x-coordinate of the vertex plus this distance, which is the square root of b squared minus 4ac all over 2a. And so when you get that together, you kind of see where the quadratic formula comes from. This one over here is going to be the same. We start at the same x-coordinate minus b over 2a. But this one we're going to subtract the square root of b squared minus 4ac divided by 2a, because that's the distance. So because this distance here is square root of b squared minus 4ac all over 2a. So we could combine that and we'd see the quadratic formula, right? That x equals, you solve it for x, minus b plus or minus, that gives you both of them, the square root of b squared minus 4ac all over 2a, because they had a common denominator. We can add them together or subtract them together, whatever that is. So that's the quadratic formula. that's what each of those points ends up looking like.